All right, welcome to this explainer. Today, we're jumping straight into the high-stakes world of hidden engineering. Specifically, we're talking about the incredible technology that's quite literally right beneath our feet. We're going to explore a fascinating industrial solution that, honestly, most people walk all over every single day without ever realizing it's even there. It's an entire system designed to fight a silent, totally invisible threat that can cause absolute catastrophe if it's ignored.
Okay, let's dive into this. Here's our roadmap for today. We'll start with the invisible industrial threat, look at the science of the spark, cover exactly how ESD flooring works, check out the high-stakes industries at risk, and finally, go over maintaining the static shield.
Starting right off with part one, the invisible industrial threat.
Picture this. You're walking through a typical, bustling manufacturing facility, maybe somewhere in Toronto. On the surface, everything looks perfectly normal. It's business as usual. Carts are rolling by, people are walking around, machinery is humming away. But in reality, there's a severe danger lurking right there, entirely unseen. So what invisible threat causes thousands of dollars in unseen damage every single year, often without anyone actually noticing until it's way too late? Think about it for a second. It's not moisture, it's not physical wear and tear, and it's definitely not a chemical spill.
Yup, the culprit is static electricity. Now, I know exactly what you're probably thinking. Static electricity? You mean like that tiny, harmless spark you get when you touch a metal doorknob in the dead of winter? Exactly. That's the one. But here is the massive catch. While that little zap is just, a mild annoyance to us, in a sensitive industrial environment, that exact same spark can permanently destroy delicate electronic components, corrupt massive amounts of data, or literally ignite flammable atmospheres. It is a massive, highly destructive force just hiding right there in plain sight.
Let's move to section 2 and see how this builds, the science of the spark. To really understand the solution, we've got to understand the physics of the problem first. So how does a perfectly normal room suddenly turn into a highly charged hazard zone? Well, it all comes down to this process called triboelectric charging. That's basically the scientific term for what happens when materials make contact and then separate. In an industrial setting, every day, completely ordinary movements are generating an immense amount of static charge. Simply walking across a floor, rolling a utility cart down an aisle, or just shifting a piece of equipment, all of that causes this charging process. Now, in a normal building, these charges just harmlessly dissipate into the environment. But in a sensitive facility, all of that movement is essentially turning the space into a ticking static time bomb. So how do we actually defuse that bomb? The mechanics of neutralizing this threat happen in 4 really distinct steps. Step 1, like we just talked about, is the movement generating the static charge. Step 2, and this is really where the magic happens. Conductive materials that are engineered directly into the floor instantly capture that charge. Moving to step 3, the floor literally acts as a pathway, flowing that electrical charge straight to hidden copper grounding strips. And finally, step 4, the threat safely dissipates straight into the Earth's ground. The static simply never gets the chance to build up and spark. Which brings us to section 3, how ESD flooring works.
So we've seen the sequence, but what exactly is this highly engineered solution actually made of? We're talking about ESD flooring, which stands for electrostatic discharge flooring. And to be clear, this isn't just some tough surface for forklifts to drive all over. It is a highly specialized epoxy or polyurethane system that actively works as a live, continuous electrical pathway. By taking the seamless durability of standard resinous flooring and combining it with integrated conductive elements, this floor literally connects the entire room to a grounding system. It creates a complete protective shield for the environment above it. Now, what's really interesting about this is the distinction between the 2 primary categories of these defense systems. They're actually defined by their electrical resistance. On one side, we have conductive flooring. This type offers the absolutely lowest electrical resistance, meaning the static charge dissipates incredibly fast. You're using this for your most extreme, highly sensitive environments. On the flip side, we have static dissipative flooring. This one has a higher resistance, meaning it allows the charge to flow away much more slowly in a very tightly controlled manner. It's perfectly suited for general static control where you just don't need that instant, rapid-fire discharge.
Let's transition over to section 4, high-stakes industries at risk.
So what does this all mean and why does it really matter? Well, when we break down the risks by industry, especially looking at facilities across the Greater Toronto Area, the stakes become crystal clear. In electronics manufacturing, just one tiny static spark can cause latent microchip defects. That means a component might pass inspection today, but fail weeks later when it's out in the real world in a consumer's hands. In data centers, a single discharge can lead to massive data corruption and total system failures. In healthcare, specifically inside operating rooms, static can actually ignite oxygen and anesthetic gases. No way, right?
And in chemical processing or any facility handling flammable liquids and combustible dust, a stray static spark can literally cause deadly explosions. We are talking about saving millions of dollars and, much more importantly, human lives. And finally, Section 5, maintaining the static shield. So, the crucial point here is a concept I like to call fragility and strength. These industrial floors are insanely tough. They handle heavy machinery all day long. But their electrical superpowers require very specific, delicate care. Simply installing the floor is only half the battle. To preserve its 10 to 20-year lifespan, you have to follow strict maintenance rules. You absolutely do need to use specialized conductive cleaners. You do need to perform periodic electrical resistance testing just to make sure the floor is still performing to spec. You do need to regularly inspect those vital copper grounding connections we talked about. But whatever you do not use standard floor waxes or finishes. Seriously, skip the standard wax. And here is why. Applying ordinary floor wax acts as a complete electrical insulator. If you put a shiny layer of normal wax on top of an ESD floor, you are instantly killing the floor's protective superpowers. You essentially trapped the static electricity inside the room, totally disabling the exact protection you just spent so much money to install. And the crazy part? The floor will still look physically pristine while doing absolutely nothing to protect you. This whole dynamic perfectly highlights the core takeaway of our explainer today. As the experts at ArmorGuard, who have over 30 years of experience doing this in the GTA, put it, for facilities that need it, ESD flooring isn't an upgrade, it's an operational necessity. It really isn't just some luxury feature you tack onto a building budget. It is the absolute fundamental baseline for operating safely and successfully in any modern, sensitive industrial environment. To wrap things up, I want to leave you with this final, provocative thought. The next time you walk through a manufacturing plant, a server room, or even a medical facility, just take a second and look down. Is your workplace unwittingly charging up an invisible threat right beneath your feet? Or is there a silent, highly engineered shield working overtime, keeping everyone and everything safe? Thank you so much for joining me on this explainer today. Keep learning, keep asking questions, and I will catch you on the next one.